So this is the elasticity questions, deformation, and this is the booklet with the answers and explanations. So question number 1, the force acts on a body. Which list contains quantities that can be changed? You can change the shape, velocity, and volume, but first three choices are not applicable because the mass can't be changed. Question number 2, force acts on a body. Again, it is a repeated question. So question number 3, the linear scale is between 0 and 10, and that is because of the straight line. Okay, so A is the choice. Question number 4, property cannot be changed, it's mass. Question number 5, what does the graph show? The graph shows that at a certain load, the wire becomes easier to extend, because look at the graph. If you apply more load, there will be a lot of extension. Up to this point, the extension and load is consistent, but after this point, because the limit of proportionality has been achieved, so after this, slightly more load will give you a lot of extension. Which object behaves as an elastic solid as it deforms? A football is elastic solid. Elastic solid means something that comes back to its original shape when the force that is applied is removed. So when we apply the force, it deshapes. When we remove the force, when we kick the football, it takes slightly bump into it, and when we remove it, it comes back. Next question is, we have 3 springs, we have 90 Newton load, and 6 centimeters when a 15 Newton load is suspended. So look at the question carefully. This is a mathematical question. So if you extend the 6 centimeter with 15 Newton, then 3 of the springs, so each spring extends 6 centimeters when 15 Newton load is applied. So what does this give you? If you divide 15 Newton by 6 centimeters, that gives you the load per unit extension. And if you divide 6 centimeters by 15 Newton, that gives you extension per unit load. So 6 divided by 15 multiply 90, that should give you 12 centimeters. So the next question is, the graph shows the extension load curves. So which fiber is hardest? Because of the slope, there is a very less slope, so this is very hard. So you can also see from the graph, very large load gives you very small extension. Extension is along y-axis. And then we have again the limit of proportionality. It will be at point B. 100-gram mass is suspended from the spring. Look at this question carefully, because this will also be a numerical in P2. 100-gram mass suspended, the top of the spring is 0 and the bottom is 27.2. So 100-gram mass and the bottom is 27.2. 100-gram mass is replaced by 600 grams mass. Okay, so when we do this, the length of the spring is 89.7 centimeters. So look at the additional 500 grams gives you an extension of 89.7 minus 27.2. Okay, so this will be a number that will tell you how much extension you are getting per 100 gram. So now you get this number and then you divide it with 200. You multiply with 200 and you should get this extension. So we see that the extension for 500 is 89.7 and extension for 100 was 27.2. So adding this, subtracting the 500 extension from the 100 extension gives you 62.5 extension for the 500. And then you divide this with 5, that gives you extension for 100. So the 27.2 was the length of the spring. 89.7 was the length of the spring. It is not actually the extension. So we calculate the extension by subtracting these two values. Now we calculate the extension for 100 grams, that will be 12.5. Now we have the extension for 100 gram and it is asking how much will be the extension for, I have written 500. This is because the 500 has been added to make 600. Okay, so bear this in mind. The 500 load has been added. The original load was 100 grams. The 500 load has been added. So after adding 500, the length of the spring goes to 89.7. So this is why we subtract 89.7 and 27.2. That gives us the extension for 500 grams. And then calculate extension for 100 gram by dividing the total extension with 5. And then extension for 200 will be just adding the 100 gram extension after this reading. So the length of the spring will become 27.2 plus 100 gram. We have just calculated extension 12.5. So adding these two together, this gives you 39.7. Next question. There is a metal wire, 1000 mm, extends by 4 mm when a load of 2 Newton is added on it. What is the length of the wire? Further 3 Newton is added, assuming that wire does not reach limit of proportionality. So again, we calculate the extension per Newton. So extension per Newton. So 4 mm is the extension for 2 Newtons load. So divide 4 with 2 gives you 2 mm per Newton load. 2 mm for 1 Newton load. And then if 2 mm for 1 Newton, so 3 Newton load will give you 6 mm. So add this 6 mm with 2, i.e. 4 mm gives you 10 mm total extension. Look at the word further 3 Newton. So that means already 2 Newton is added, load already 2 Newton, and we add further 3 Newton. That makes the total load 5 Newton. For 5 Newton, the total length of the wire will become 1010 mm. Look at this graph again, very important. These questions are very important. So the spring is showing its behavior through this line and it hasn't reached the limit of proportionality. For 100 gram, it is 1 centimeter and then so on. For 200 gram, the length of the spring was 9 centimeters. Okay. So the 200 gram is replaced by 100 gram. What is the new length of the spring? So we know that every 100 gives you 1 centimeter. So removing 100 will take 1 centimeter. And that's why it will go back to 8 centimeters. So this is the original length of the spring and this is the length of the spring after suspending 10 newtons. So the spring is extended by 3 centimeters for 10 newton. If you make it 20 newton, another 3 centimeter will be added. That will make the total length 11 centimeters. Okay. And then we have this very simple question, limit of proportionality always on the straight line, linear line, this will be B. And then we have the graph, again, same question, limit of proportionality is P. And here we have this question that has been done so many times in class, you don't need this explanation, you should just know that the load suspended by two springs will become double if it goes on one spring. So if it is the x, it will become 2x for one spring. So the total extension of both springs will be 2x plus 2x, 4x. This is an extension load graph. So limit of proportionality lies at 60 Newton load. After this, it takes the curve. And here, well, this is not from this one, so ignore this. Just look at the answer. You can work it out yourself. So next question, it is delta is the correct choice. Why? Well, we can see that all other are invalid. This is not possible. This is not possible. This one is possible, but you can't have this way. It has to go like this way. Okay. Next question. Again, a graph is given. The load is 0. The length of the spring was 2, and it increases linearly. So 3 centimeters. So look at the 3 centimeters from 2. It will give you 5. The original length spring 2. You add 3 centimeters. Okay. Extended by 3 centimeters. A load causing the spring of the balance to extend by 3 centimeters. So if it extends by 3 centimeters, the total length becomes 5. So 5 gives you 15. So that's why the balance reads 15. And then we have a metal wire, and it is the same question that is repeated. And in this question, there is some missing data. It was 14 here and so on. So we can clearly see that 14 and then 16 and then so on. And this, the limit of proportionality will be as long as there is a linear relationship. So for every 2 to 4, the extension is increasing by 3 to 6, 6 to 9, 9 to 12, 12 to 50. Sorry, it was 15 here and so on. So although we have missing data, but the correct choice is C. If it comes out, you should just remember it. So we have 30 Newton by 2 springs, and the extension of the spring needs to be found out. So the spring extends by 4 centimeters when 10 Newton load is suspended. 10 Newton gives you 4 centimeters. 4 divide 10 and then multiply with 30 should give you 6. And then this is the last question, cannot be changed, is math.